This is Orion O6, world's first open source ARM v9 motherboard. Wow, that's a mouthful. At this precise moment, it is crunching ones and zeros on the dedicated neural processing unit to generate an image from the following text description. Not bad. In 20 seconds, while using almost none of its 12 CPU cores. So what else can this board do? And is it worth the price tag? I got Orion O6 following a comment on my other video. I contacted Radxa and asked for one unit for testing and review. Little did I know what exactly I'm walking into. Turns out this board is actually kind of a big deal. There are plenty of low-power ARM SBCs that are meant to be used for development and DIY. The most famous example here is of course Raspberry Pi and other fruit pies. Apart from that, ARM architecture is used in Apple Silicon Macs and Snapdragon X laptops. You might notice the glaring gap. There's not so much available for desktop, certainly not at any affordable pricing. Orion O6 promises just that. A mini ATX form factor board with an ARM CPU and integrated RAM that can be built into a full-fledged desktop and used as such. The specs are pretty cool. 12-core CPU with 4 of each type of cores, big, medium, and little, an integrated G720 ARM GPU, 30 TOPs NPU, up to 64 GB of rather fast DDR5, a bunch of interfaces, and a PCIe X16 physical slot. So a potential to add a standalone GPU. No integrated Wi-Fi or Bluetooth, however. You need an M2 key module for that. And maybe irrelevant but a touchy little detail is the presence of Raspberry Pi compatible 40-pin GPIO header. Let me say that I'm straying away outside of my comfort zone in this video. After all, I mostly talk about lower end devices on this channel, aka the truly embedded boards, and how to use them in robots and IoT systems. That's why I don't want to spend too much time talking about interfaces or PC benchmarks. There are people who already did some great reviews of this board. For example, this video by Jeff Gerling. Watch it after for a more complete view on Orion O6. The link is in the video description. What I want to focus is my own experience with this board and what is the board performance and usability with regards to AI. The overall bring up and user experience as of now is not great, but also not terrible. I have seen worse. You need quite a few things to actually start working with the board, namely an NVMe SSD. I had to quickly get one. 1,000 praises to modern technology and one-day deliveries. You also need a USB 3.0 flash drive. USB 2.0 also can work, but from what I hear, it's going to be painfully slow. The software for the board is being developed still, and documentation does not always keep up. The docs suggested to flash an image to USB drive, boot into Debian from that USB drive, and then use pre-installed Etcher to flash yet another image onto NVMe SSD. But in fact, that Debian 12 desktop ISO B6 image is simply a Debian installer. What complicated the situation was that the BIOS on my board was pretty old, 0.2.x version. So I could not get the video output after pressing install. Imagine my mad confusion. Finally, on advice of a random internet stranger on the forum, I updated the BIOS and was able to flash Debian 12 on NVMe storage and put into it. Brand new SBCs and ARM desktops are great, but there's still a lot of people in developing countries of Africa, Asia, and Middle East who do not have the means to use a regular laptop or internet. That limits their access to education and skill development. This is where our today's giveaway contest comes in. Fill in the Google form in the pinned comment to take part in merch giveaway. I will select 3 winners, and there's some really good merch there. While you're doing that, take a look at Give Internet Foundation website and help them by either donating or spreading the word about them. FYI, this video is not sponsored by either Radxa or Give Internet Foundation. Radxa simply provided a sample with no strings attached, and Give Internet found me through my other video and asked if I would like to help to promote their cause. problems. They're doing a good thing and they're being transparent about it. So I agreed. The board with Debian 12 OS can be used pretty much as a regular Linux PC. So you can do your PC things there, like browsing internet, watching movies, playing some games. Not saying that the last one will be easy, since it is 64-bit only CPU and Arch64 architecture Linux. But it's possible nevertheless. I ran Geekbench 6 out of curiosity to compare the current results with the results from Jeff's video. The scores are on the screen and they are in line with previous results. But a much more interesting part for me was AI performance and usability. To find out the complete extent of AI capabilities of the board, you need to register with CIX Early Bird program and receive a link to the coding repository where they store the demo code. I got very excited seeing so many large language models listed under generative AI LLM, only to find out that for all of them there was a single .md text file suggesting I run models with Llama.cpp on CPU. Okay, thanks. Since this board aims for a desktop PC build, I checked the performance of slightly larger 14 billion models, which are quite usable for generic tasks. And for smaller models, here is the performance of 4 billion Llama 3.2. The important thing here was that using Llama.cpp over ollama and specifying the core affinity for the executable. Ollama was using maximum allowed number of cores, which included the slower cores, the little ones. It slowed down the inference slightly. But not all hope is lost, because at least for other types of neural networks, there is a possibility to use NPU. Obviously, there are various image processing tasks, such as object detection, pose and depth estimation, face recognition, and even image upscaling. More interesting was seeing whisper-based speech-to-text and Stable Diffusion models. Looks like SD 1.4 can be run completely on NPU, while SDXL is in part executed on CPU with ONNX runtime. For SD 1.4, the execution is whooping 10 times faster with NPU than with CPU. Since diffusion models are transformers in part, it means that accelerating LLMs with NPU is also possible, and hopefully it will be added in the near future. Overall, I agree with Jeff when making a verdict for the current version of this board. While hardware looks very promising, the software is not yet there. You probably should not be rushing to buy the board yet, unless you're a die-hard ARM enthusiast and you prepare to spend weekends debugging. I think it will be good to make another review about this board in a half a year's time to see if software has matured a bit more. Subscribe to the channel to get notified about that and other latest stuff in AGI hardware.